So, welcome everybody. Let's start this webinar series that we call Heats Focus. This is a new series that we're going to hold on a regular basis, where we're going to focus on a specific feature. It could be old or it could be a new feature from Heats, and put some highlight. And we're going to try to keep this as an informal meeting. So please submit questions in the chat or raise your hand and speak up if you have any questions or things that you'd like to share. So please have this as a interactive session. So just some other note here, this meeting will be recorded, so please be aware of this. And yeah, so we're going to try to keep this pretty fast as well. So we have 30 minutes. We're all busy in our work day, so we're going to try to be as efficient as possible. But we're going to stay online after the event. So if you have any questions or things that you'd like to discuss, just hold on. All right, so the topic of today is Heats posts. As you know, one of the big challenges working with design studies is that you're going to create a large amount of data that you need to gain some insight from. With Heats post, you have a lot of different functionalities and type of plots that you can use. But one feature that came into to Heats post after the release 2020.1 was a guided workflow. So as you can see here, prior to 2022.2, you had the Home tab, where you had access to creating different plots and reports and custom views and whatnot. But after 2020.2, we have 3 new tabs that's going to guide you and help the users to transform the data into insights. So these are the tabs that we're going to focus on today. What are they and how do they work? And please make comments and also explain how you use Heats post today. So each of these tabs has a purpose. So the first one is Discover. So it's basically a way to help you to make different plots, different combination of plots to discover different clusters or different kind of designs that are similar enough to gain some insight into the designs that you're after. The second tab, called Plot, is a way to use a canned type of plots that will help you to highlight the design set that you have identified from the Discover phase. And lastly, we have the Investigate tab, which will give you some tools to investigate the design set and find influence correlations and things like that to actually find some value in the designs that you have filtered out. So traditionally, we have a bunch of designs that we get from the study run in Heats. You can create subsets, different design sets of all these designs. Could be feasible, unfeasible. You can filter in any way you want. And then you would make plots and combine them into views. Use those views to find insight and trying to investigate how your study behaves. So with the new workflow, the Discover tab is basically a way to identify design sets that will be further investigated. And then you have the plot tab and the investigate tab to highlight this design set, investigate how these connects to each other, and then at the end of the day, finding the best possible insights from your study. So each of these tabs starts with a source. So from the source, you select what design set that you want to start off using. It could be all designs, feasible designs, or a subset that you have created earlier. Then you have a method that you're going to use, and then at the end, you create a new design set. So based on the method, you can filter out a new design set that is more honed into your objective. The second tab, plot, will also use a source where you select the design set, and this could be the one that will be the result from the discover phase. And the results from the plot method will be either a plot or a parameter series. These plots will be saved, or when you save them, they will be saved for in the study, so you can use those in the plot views later on. And lastly, the investigate tab again uses a source, and then based on a method, it's going to create plots or parameter groups. So the purpose, for this purpose, we're going to use an example. It's a heat study that has been priorly run using an electrical motor. We're not going to dive into any details about this study. Basically, we just want to use the resulting design set from this run. There are going to be a bunch of different parameters, so some general settings, some rotor dimensions, and stator dimensions. So quite a few design parameters. And we're going to have a few objectives or responses, and there are going to be 4 objectives. So torque, speed, efficiency, power, and so on. And we're going to also look at some different kind of torque effects, like torque ripple and so on. So real quick here on the problem that we're going to be looking at, but now we're going to dive into the heat project. So quite a simple process. We start with a motor solve, and then we use another analysis to get the mass. So if we look at the parameters that are used in this study, we have 10 responses, as we mentioned. A few of them are tagged, another are calculated based on a formula. And we have 12 design variables. So the study will be using 4 objectives. So the torque and efficiency, we're going to try to maximize, and the RMS value, and also the magnet mass is going to be minimized, and we have 1 constraint. So this will be run, or it has been run, and based on the design study, we have 254 feasible designs. We got a few error designs and also a few infeasible designs. So this is the data that we're going to try to investigate now. So when you go into the posts tool, we now have these 3 additional tabs. So previously we had the home tab, and we had all the functionality and the features from here. So we still had a large list of different kind of plots. We could create custom views, could create design sets and things like that. But it was all up to the user to start to combine different responses, variables, and things like that to try to investigate the study. So with the guided workflow now, we have, as we mentioned, we're starting off with a source. So either the complete study, or we can select the standard design sets, or if we had created some other design sets before. So let's select all the feasible designs. And now you're going to select the method. So the first one is closest. So based on the design parameters, you can select one or multiple. If you select one, you get a scatter plot based on the design ID. And you define a threshold. So you want to filter out all the designs that are within a certain range. As you add on more parameters, now we get a two-dimensional scatter plot with the two design parameters. And we can play around with changing the threshold. And as you add on more parameters, it's going to change the plot type. So it's going to be easier for the user to look at. Or you can select all the parameters that are available for the study. The second one is similar. So it's sort of like the closest, but now we're going to try to find designs that are similar to each other. Or you can select clusters. So it's going to, here you define how many clusters do you want to identify these design sets into. So you can, right now it's set to 4, but you can change that to 3, and then it's going to recalculate. And we have some advanced options as well here. So down here you define the size of the cluster. So it's going to recalculate and finding clusters based on the size that you define. The next one is trade-offs. So here you select the responses. So if we look at the torque and efficiency, for instance, we're going to get a scatter plot based on these two responses and finding the trade-offs between these two. And the last one is pattern, which using the self-organizing map to organize these different designs. The nice thing is that you can go back and forth between these buttons depending on what you're finding. So maybe you play around with the trade-offs, finding different responses and finding an interesting relationship. Now they're going to be included now in the closest plot. So as you can see, these are added into the parallel plot that we see here. And now you can tighten the ranges, or you can include or exclude different design parameters as you see fit for your design. So once you have created the relationships that you find interesting, then you go to save the design sets. So it's going to select the ones that you have filtered out. And now we're going to see this design set in your list. So closest 20 was the one that we just created. We obviously didn't have any suitable ranges, so we only got the one design. Next one up is the plot tab. So let's say you have discovered a design set that you find interesting. How do you create plots that are visualizing these different interactions? So again, you start with a source. And since we only had one for the closest, let's continue to use the all feasible designs. So then you can create 3D plots. You have access to parallel plots, 2D relation plots, and history, or you can create some other plots as well. But it's all based on the discover phase. So once you create these plots, then you go into save, and now we've saved this new plot, and that's going to be available for you later on. So the third tab, the Investigate tab, again, we start with the source. So you select the source you want to use. And now you have different tools here available to dive into the responses or the parameters that you have identified to be interesting. The first one is influence. So this will be, you can flip this between finding variables that influence certain target response or find responses influenced by certain target variables. So you can go both ways. And so if we select torque, efficiency, and ripple, well, let's use 2 for now. So if you select these 2, then you click compute, and it's going to create the influence plot based on Borough. And here's the result. So we get down here, we have all the variables included, and we select the 2 responses, the torque and efficiency. And here's the influence based on this. The next method that you have available is correlation. So if you want to find correlation between the different design variables, so you can change the thresholds, the range that you want to look at. And this is something that you typically would use with a manual approach as well. So it gives you a good highlight of how does these design parameters connect to each other and finding relationships between them. Next one up is sensitivity. So if we select the torque, then we have a surrogate model. And then we have the torque is based on all these selected design variables. So now we're computing the response based on the response surface or the surrogate. And you can include others as well and mix and match depending on what's needed. Just click compute and it's going to recalculate these. And here you can create new surrogate models based on the design study. So if you select a certain design, then you can go in here and create a new surrogate model. You can use that surrogate model back in the sensitivity study. You can go back and forth as you see fit. So we have one that was previously created. The torque was based on the Kriging. And you can right click here to create new surrogates. So if we want to use the efficiency, for instance, we click next, and then we have all the design variables. Maybe we want to use a radial basis function this time. And then we have a new surrogate model for efficiency. And when selecting the efficiency, we can now select this surrogate model. The next method is a neural network. So this will basically allow you to use the data that you have created here, export a neural network that you can then use in either the ROM builder, or you can include this in another design study if needed. And the last one is explore. It will basically allow you to select the responses, select what you want to look at, vectors, tag responses, or formulas. And then you can toggle through different designs to see the all the response values. So as I mentioned, you have the output from the Investigate tab is that you can create a parameter group. And that can later on be used if you want to do other type of studies based on this output, or you can export it to the ROM builder. So the based on these 3 different steps, we now have created additional plots. We have created additional design sets, or maybe even parameter groups. So then you can go back into the Home tab as you usually use and continue to create new plots or new combinations to create plot views, for instance. So the plot views can now reference these plots that you have identified through the guided workflow. And then you can include it in reports or anything like that. So it's basically a nice guided process that you can follow to guide you through the steps to investigate all the data that is available, instead of manually mixing and matching and trying to find the designs. A lot of times it can be fumbling in the dark when you're not sure what you're looking for. It's supposed to be a guide and a help for you to be more efficient in processing all the data. So do we have any questions, or anybody would like to make a comment of how you're working today? All right, so then we saved some time today. This was the different steps that we wanted to highlight and capture today. But I'll stay online a little longer in case you would like to discuss something else here. But hopefully you can get some good use out of this guided workflow and be more efficient in your design studies. So thanks for joining today.